Make sense? Agree? Yes? Okay. So we're going to look at active design today, because that's where most of the HVAC is. So, and I'm going to primarily focus on cooling, because heating for us is very limited, and it can be taken care of passively in Phoenix climate. So just different types of HVAC systems. We have the cooling only system, heating only, and cooling and heating systems, major categories. And then in terms of distribution, there's decentralized and centralized type of systems. When we go into centralized systems, there are three more categories. There are the all air system, air and water system, and all water system. And we'll talk about these things. So we're going to primarily focus on cooling. Went good? Okay, before we get into the different types of systems, let's take a moment and understand refrigeration cycle. There are basically two types of refrigeration cycle. One is the compressive refrigeration cycle. The other one is the absorptive refrigeration cycle. In concept, they're the opposite. In simple terms, let's look at compressive first. There is a compressor which consumes a lot of energy, and I mean, does everyone feel comfortable with refrigeration cycle? Should we skip it or should we look at it?
Go through it.
Go through it? Okay. So there's two parts to the compressive refrigeration cycle. There's the low pressure part and the high pressure part. Refrigerant is commonly used. There are several types of refrigerants, and that's another important item to be noted. Refrigerants are harmful to the environment, to the ozone. So certain type of refrigerants are restricted to be used. The ones that we use are hydrochloro HCFC. That's the one that we use. The ones before that are abandoned.
The HFCs and then the R22's gone.
Right. Yes, we could use ammonia too, and that's a very good point, Tim. Ammonia is the problem with ammonia is it can blow. It's flammable.
Yeah.
The next version of HCFC, hydrochlorofluorocarbons, that's the one that we are using, is HFC, hydrofluorocarbons, and then the last and the super version is the hydrocarbon. But the problem with the hydrocarbons is flammability. So it is important to know which type of refrigerants we're using in our projects too. It's not only on HVAC design and equipment, but it's also on refrigeration. Anywhere refrigerant is used. So anyways, let's go back to the refrigeration cycle. So the compressor, by the movement of the compressor, it pressurizes the refrigerant, and then on this condensation side, the pressurized refrigerant is liquefies, and that comes back, and using this expansion tank, it gets expanded, and this is the evaporation side, and this is where it loses heat, rejects the heat. So we couple our chilled water, the warm water comes into this, and it rejects the heat, and chilled water goes back to our building. And this is our typical cooling tower scenario, where the warm water goes to the cooling tower, and it comes from the cooling tower and loses its cool to this refrigerant, and then by heat transfer, cool from the cooling tower is brought back to our chilled water lines. Everyone good? Okay, so if we take this and sort of reverse this, that's the absorptive refrigeration cycle. So, you know, the simple solution, a simple way to think about absorptive refrigeration is if you put our table salt in just on our table, eventually it'll start absorbing moisture. Whatever's in the air, not in Phoenix, but in other places, it will start to absorb moisture, right? So that's the process here. So we'll have a salt solution on one tank, and then water on the other tank. And this salt solution will naturally start absorbing the moisture from this water tank And we pressurize this and we put a pump to make this process go faster. And on this side, evaporation takes place, so you go ahead and put your condensing coil heat exchange. So that's where you supply 55 and it becomes 45. And absorptive refrigeration is not as efficient as compressive. But the advantage here is you could use solar here to enhance this process than just the pump. So solar absorptive chillers is a very interesting concept. The advantage also is you use solar. It's kind of ironic that you use sun to produce cool, but it is an actual technology.
Byproduct.
Yes, and you can buy this chiller, solar absorptive chiller, where the byproduct of this process is heat. So it makes most sense to have a combined heat and power.
When you have a process that requires heat all day, every day, it's the byproduct there is the cooling side of it. So you get free cooling out of it if you have this boiler or solar powered system running all day,
Right.
every day.
That's that way a gas powered refrigerator works.
I think you're right. Right.
So it makes most sense because most of the time when we need cooling, we have a lot of sun outside.
Right.
So
But the only way that works is if you actually get rid of that heat somewhere else.
Right.
Have a need for that heat all day, every day.
so it'll be best for say an aquarium or something, or where you have a huge water need, hot water need. So everyone good? Two types of refrigeration. Mostly, that's what we
That's
do.
what we typically see up there. Correct. Most
And
clients
this is
are
something
using-
that we should look into because it has some potential, even though it's less efficient.
Yeah, I know a lot of the community colleges had the absorptive refrigeration, and they've taken them out.
Okay.
And on eBay, we kind of looked at that,
Okay.
and I think it was like, I forget if it was about other than, I think the absorptive chiller was really expensive.
Yes,
They are very expensive.
very
And
expensive.
and the other issue was the heat.
You have to get rid of it somehow, some way.
Right. So that's the same with the fuel cell technologies too.
Then you have to use cooling tower to get rid of it, or.
Right.
or-
So it's similar to the fuel cell technology where it generates clean energy, but it also puts out a lot of heat. So unless you have a need for that heat, it doesn't make any sense to put these things. Okay, so we're almost done here. Cooling systems, I try to make this simple rather than without having to go into each type of systems. So I'm going to go from the lowest cost to the highest cost and just talk about it. So the first type of mechanical system that is the lowest is just a ceiling fan. And we use that in our houses.
Get that air circulation.
Get that air circulation. How many of you remember how many feet per minute I have to move
30.
the air to increase 1 degree?
30.
50 to 30 feet per minute. If I increase that, then I can increase 1 degree in terms of comfort. But the problem with that is you keep adding 30 feet per minute, and after a while you can't stand that.
Paper doesn't stay on the
Right.
table, right?
Right? So you can effectively go up to 83 degrees. You can stretch the cover to 83 degrees, beyond which, if the outside air temperature is 100 degrees, you still need another form of mechanical cooling.
Gotcha.
So fans can only go to some extent.
Okay.
But it is something that we should look at. How many places? I mean, we should try to. I mean, I've been trying to put these big ass fans on all of those projects. Try to move these things so that we can
Did you buy
reduce our
stock in them
energies.
and that's why you're trying to do it?
No. Okay, so the next form of that is, this is a glorified fan basically, because there's no compressor or anything in the unit. Air conditioners, just our window units. There isn't correct me if I'm wrong, Dave, there is no compressors in those
Yes.
things. There is?
The window shakers, the.
Yeah.
Or a point of use air conditioner.
My understanding was there's only a fan, and then there's a refrigerant that gets moved back and forth, but outside air is used as the sink.
compressor rejects that heat similar to our other units.
Okay. My understanding was those air conditioners didn't actually compress, and there's no low pressure, high pressure on these guys.
That I'm not aware of.
I'm not sure. But anyways, nobody ever uses it.
I think the ones, window shakers you buy at Home Depot or whatever, and the ones that are in your hotel room, typically that like that are your single zone, your air.
These guys?
Right.
Right.
Typically.
And I think there is a difference between
Okay.
unit air conditioner and this.
Okay.
And I'll find out more on that.
Sounds good.
So then then we have the evaporative coolers and indirect evaporative coolers. This is something that we've started to propose on our projects, indirect evaporative cooling, because it uses the evaporative cooling's advantage, and it deletes the disadvantage of moisture adding into the airstream.
Yep.
So this is something that we should start looking into if there's an opportunity. The only problem with these two are
Add maintenance.
maintenance, 1, 2,
Space.
okay, space maybe. Water, we need water, because we're going to spend a lot of water in these things.
Yeah.
So if water is a big concern, then we may want to think about this. So there's some trade-offs back and forth, okay? And then air-to-air systems. So air-to-air systems meaning, as Dave mentioned, primarily the heat sink is the air. So
Rejecting the
we
heat to the
reject
air,
the
or
heat
you're
to the air.
drawing energy from the cold air to make
Correct.
heat.
Right.
Heat.
So primarily the system depends on air. And the single zone, we see this more often. And multi-zone is something when we get into a bigger project like a prison, we get into multi-zone.
Do you use those?
So a hotel room heat pump, is that a single zone?
It is a
Yes,
single zone.
it is a single zone. And VAV is something that we use most often. The problem with each one has its own maintenance and own cost differentials. Single zone is very effective because it solves the local need right away. But the problem with this is, and I have 50 of these to maintain, as opposed to having one multi-zone system.
VAV system.
But the multi-zone system or the VAV system will have a lot of ducting because it's central and it goes from one place and covers most of it. So you need more room. So from a design standpoint, I think it's important to first figure out at least, first figure out 85, 15% difference, and of the 85, how much can I actually do in my project? Let's say it's only 45% passive technologies. So then my HVAC is 55%. So off this 58%, we should have an idea of where the budget is, right? Typically, budget drives our selection. We should have an idea, and because that will determine how we design our buildings. If we go with a multi-zone or VAV, we have to make sure we have plenty of ceiling space.
Yeah. Also, though, it's dependent on the kind of use, because you would never do a VAV in a hotel that's always on.
Right.
Because hotel rooms shut down; they just turn them off.
Correct. So we'll look at those criteria for system selection in a second.
Okay.
Air to water systems. Air and water, I guess. Air and water systems. This is something that we're currently using in PV32, where the air, the water part is from the fan coil and a central plant, and it's centralized, centralized cooling, localized heating through electric heaters, and localized supplemental air through local ventilation. So we don't have a huge centralized air handler to distribute take care of all of the classrooms. Right. And then the other common air and water systems, the radiant panel system, where you separate the heating, cooling part from the conditioning part, air part. Then the last one is all water system, like the 4-pipe system, and here it's assumed that you take care of air separately. So just from a cost standpoint, this is the highest in cost. And most often, we use a mixture of all these things.
There are hybrids of all those, correct?
Right. So
I
for
would say that one of the things that's become popular are the chilled beams. And that would be more
similar to the
of
radiant panel.
the radiant panels, the all water, where you're actually just running water, either hot water or chilled water through the beams, and they're absorbing the energy from the space or radiating that energy to the space.
Correct. So, so knowing that will change our design a lot.
Right.
So we have to make sure which system we're planning on doing to take care of that 45% gap.
Would in-floor fall under the all-water?
Which system?
In-floor heating? In-floor?
Radiant? Is that-
Well, when you do run your tubes in the
Correct.
in the
Correct.
slot,
All
Yep, that will be air and water system.
that would fall under air and water.
Well, they have done radiant cooling, so you actually cool the slab, and that cooling radiates the space. It works in places where the humidity is low, which helps. You don't want to let that moisture that's in the air
Will condensate.
become a puddle on your cold slab.
But what about forced air underfloor?
Forced air, so that's an
That's
air side, and
VAV.
it can be probably a hybrid, either using the
Right, it could be a hybrid of these
your
things.
heat rejector or your water side.
Okay.
To create the cold air that you're pumping out of the floor.
So, and I think to help us, so you can have any one of these, and it's million combination.
I think those indirect evaporative coolers are being combined with your refrigeration cycle to kind
Right.
of pre-treat things before you actually run your compressor also.
Right. So how do we decide on what system to use?
Well, actually, are you going to tell us?
Yeah.